Once again, yeah, I don't know if there's any lead. I might want to take a pen instead. Okay, surface area. Today's main point of the lesson. I'm going to warn you right now. It's not going to always fit your formula. Okay? So out of all the stuff we've talked about so far, the one thing that I want you to put an asterisk or a little star next to is surface area. Put a little star next to the title and say, won't always fit the formula. You can't blindly plug numbers in. Okay. For example, take a look at the back of your formula sheet. You will see on the very bottom this thing called a triangular-based prism. The formula for the surface area, in other words, the middle column, that's really complicated. And you could try to nitpick where all the numbers are and try to plug it in like a robot. But I believe that it is going to be so much easier if you are willing to use your head a little bit. It's actually harder, and it gets harder to follow a formula for surface area if you are just blindly looking at this and not going to try any of these questions. And you will see that when we get to the last 3 examples in this sheet. All the homework questions, well, you can try later. I will start with some of the easier questions, and my goal and my hope, cross fingers, is to go through all of these because it's useful, unfortunately for you. Let's talk, okay? I may skip a couple just for the sake of time, but we'll see where we go. All right, please turn to today's lesson, the actual handout. And as a reminder, tomorrow there is going to be a kind of, mini homework check quiz. It is, let's see, just because there's a lot of room for little formulas and stuff like that, very simple, straightforward questions, and 1 page double-sided with little shapes. You can calculate area, volume, surface area, whatever. It's essentially homework level questions. But that means you have to have some practice. So I hope you were being responsible this week. I did warn you ahead of time that the turnaround was very quick, right? And it's not going to be a big test. It's just a small quiz for this. You are free to bring this formula sheet with you, have whatever else you want to write down on it. You can use this as your study sheet if you want. I'm okay with that. But that's why I'm saying you're getting this, but I'm still getting you to practice. Why? These questions may not always just simply be plug in the numbers and get me the final answer. Questions will ask or we'll see if you are thinking for yourself. Here we go. If I could find my stylus, that would be great. All right, surface area. Surface area is a measure of how much material is required to, I'm going to use the words cover or surround. Tightly. Just cover or tightly surround. And another way we can look at this is to look at these 3D shapes like geometrical nets. Does anyone know what I mean by nets in geometry? What do I mean by that?
Like in school, we used to make those like shapes flat.
Yeah. And then like with the dotted lines. Absolutely. Yeah. So you know that if you have a piece of paper and you cut it in a certain way, you can fold it up and turn it into a 3D shape. That's the surface area, the area of the surface. If you open that up, that net, and measured how much space your piece of paper covered, that's what we will be calculating. And so some people who are able to see things in 2D and in 3D at the same time, you sort of have a bit of an unfair advantage because you're used to this. Some people who are not as strong with the spatial visual abilities, don't fret. That is why we are here to practice based on formulas. But long story short, if you take a look at this, I'm going to try to break it down in hopes that you'll be able to see what I mean. In this shape, there are only 3 different rectangles. Think about that. The first rectangle is this large one right here. And there are 2 of them. One in the side that you're able to see, and one on the other side. Maybe I can draw this. One on the other side right here, or one on the other side. Does that work? You see what I'm trying to point at? Okay. One on the other side that you might not be able to see. Okay. There's 2. So let me write that. There is, I'm going to call this number 1, 2 faces, right, or 2 faces that I'm going to call the blue sides. And what are they? They look like this. It is a rectangle with a base of 4 and a height, a base of 6 and a height of 4. What other rectangles do you see? Ron? The front right here? Sure, let's color that red. This is a bit of a wider, a little bit, same height, a little bit thinner rather, what am I saying, not wider. The second shape I see is the one on the front, and of course there's going to be the other one on the back as well that you cannot see. There are 2 faces, and I'll call them front, back. And what is that rectangle? That is 3 and 4 as a dimension. And lastly, I'll color it in green. Which shape is left? The rectangle, yep. Top, and of course the bottom. That is what I mean by the spatial visual abilities. You obviously cannot see it directly, but you know it's there. So I have to say that there are going to be 2 faces. That's the top and bottom, top, bottom. And that has a rectangle. I'll do it like this. That has a base of 6 and a width of 3. So again, imagine this was a net. If I opened it up, I would have 3 different rectangles and 2 of each. Stopping right there, go back to the formula for surface area of a rectangular prism on your sheet. The formula says 2 of WH plus LW plus LH. You could memorize that. But for me, I think it's more valuable that you are able to see visually what each face is and calculate the area accordingly. There's no value. It doesn't improve your thinking and your logic skills just to plug numbers in. So as a math teacher, there's what I desire from you in hopes that you'll be able to level up from where you were, let's say, in grade 8. Okay? That visual ability will absolutely help you, especially if you are interested in things like physics. Moving on. So what is the total area? Well, it will be 2 of the area number 1, right? Rectangle number 1, plus 2 times the area from rectangle number 2, plus 2 times the area of rectangle number 3. What is area of the rectangle number 1? 6 times 4, 24. 2, 3 times 4, that's a 12. And 2 times 6 times 3, that's an 18. You add that up together. I already did the answers on my own time. The final answer is 108 centimeters squared. Correct. That is what the formula is saying. And if you understand where that 2 comes from, I think it's more valuable. Like, why can we just add it all up and multiply it by 2? This is why. Exactly right. So you can add up the area of all 3 triangles and then multiply it by 2. You should know where they come from, where that equation comes from. Any questions? Good. I'm going to move on because I'm not going to insult your time or your patience. All right. In the same way as I did before, what shapes do you see for this one? Let's list it. Yep. Base is a square. I have 1 square. Good. What else? Yep. 4. Are they all identical? Is every triangle identical? Good. Okay. Case in point, sometimes everyone, if I was really mean, maybe I would give you a rectangle-based triangle, pyramid. Like, what if I gave you something like this, where clearly the base is not a square? What if I give you like 6 and 3? All 4 triangles would not be the same, right? So just to be clear, in this particular one, it's not. So you can think for yourself. That means I need to find the area of a square, and I need to find the area of a triangle. What is the formula for area of a square? Or any rectangle, really? Or length times width, or base times base, right? What's the formula for a triangle? Keep going, Warren. Top of your head? You know it? Base times height divided by 2. Okay, let's do the easy one. Area of the rectangle, base length times width. Yep. 6 times 6, which is 36. Good. Okay, careful. When we're talking about the triangle, I am not talking about the height of the pyramid. Visually speaking, I need you to be able to, let me highlight this. I need you to be able to take this slanted triangle and put it flat on the ground. And if you put it flat on the ground, like a 2D shape, do you see how the base is a 6? And this is my 12. You need to turn it into things that you understand. In elementary school, I know you were given triangles and asked for the area. Well, here is a 3D shape, but you can pretend each side is 2D and calculate it individually if you want to. With that in mind, the area of a single triangle is, I'm going to leave a space here, base times height divided by 2. And once you have the area of one triangle, remember there is 1 face, 2 face, 3 face, 4 faces. You have to multiply that by a 4, which gives me, let's see, 72, 36, 36 times 4, 144. The total area is 144 plus 36, 180 meters squared. It is very important that you don't blindly plug in the numbers. Please take a look at, and I'm going to show you what I mean even on video. Yeah, on video. Please take a look at the formula for square-based pyramid right here. It says b squared plus 2bs. And it's your goal to try to figure out what b is, what s is, and, you know, not that it's actual bs, but you know what I'm talking about. Okay? It's not bs, people just letter b and letter s. Okay? But again, instead of learning how to plug in a formula, I think it's so much more valuable for you in your growth to know where it comes from. Case in point, the formula for a cylinder, 2 pi r squared plus 2 pi r height, who the heck made that up? We'll take a look. Well, this is a good one. Anyone ever wondered why the surface area of a cylinder was 2 pi r squared and 2 pi r height? It's worth thinking about because again, there's a logic behind it. Yeah.
Well, when you're finding the area of cylinder, isn't it finding the area of 2 circles in a rectangle?
It is. But where did that come from? Where's the logic in it?
Because like, say you actually had cylinder and you top on the side
Right.
and fold it out.
Right. So I'm going to demonstrate that. Excellent. Let's start racking up the points behind these. Okay. 2 pi r squared. Forget this equation. Pretend that's not even there for now. Okay. What surfaces do you see? Yep. 2 circles. Let's work with that. There's a circle up top, and of course, the same circle on the bottom. What is the area of a circle? Pi r squared. I have 2 of them. So 2 times the area of a circle is 2 pi r squared. Oh, that's where it's coming from. Okay. So this must mean that it somehow calculates the outer rim. And as Maddie was saying, you have to use your imagination. The reason why we have a 2 pi r h is because we are going to look at it from not a circular perspective, but from a rectangular. Everyone see here, pretend this was my cylinder. Chop off the top, chop off the bottom, it's hollow, there's no surface, okay? If I were to take wow. If I were to take scissors and you cut it straight through, it would in fact turn into a rectangle. What's the area of a rectangle? Length times width. In this case, do you see that the width is a 15? So what's the length? The circumference of the circle happens to be the length of the rectangle. They're one and the same. So if you were to say, right, I have this and I turn it into a rectangle and I want length times width. The width is right here. The width is still 15. But check out my highlighting. My length here, if I rolled it up, is this. That's why we have length times width. My length times width is circumference times the height. So there's a logic behind it. I don't want anyone to think that someone just made up these formulas and was like, the entire world will follow me. No, there was a logic behind it to make life easy. It is so much easier to look at shapes as a rectangle than it is a cylinder. And so they made the connection and said, you know what? It is a cylinder, but it is a rectangle. So here it is. Let's calculate this all together now. 2 pi r squared is 2 times pi times radius squared. If I were to multiply this out, 2 times pi times 64 turns into, believe me when I say, 402.12 centimeters squared. The area of the rectangle, which you know its length times width, is the same as saying circumference times the height, which is 2 times pi times 8 times 15. R is 8. H is 15. And if you plug it all in, I'll do the calculation for you. This is approximately 753.98 centimeters squared. So together, I will add it for you. This becomes 1,156.10 centimeters squared. Yes.
On the formula sheet, it's like that your area is pi r squared, not 2 pi r.
Yes, the area of one circle is pi r squared. But I have two. Yeah. Correct. Right, so I wrote two areas of a circle and then one area of a rectangle and just added it together. Okay, I'm being unconventional. I'm not following the formula. I'm trying to use logic to piece it up. Yes, Amy. Oh, if you have the calculator, most, if not all calculators will have a button that you could do that. You can press it. If you don't have it, I am okay with you just writing 3.14 as numbers in the calculator. Your phone could have it, but you're not allowed that on any test. So try to keep it. By the way, whose calculator is this? Someone lost it in this class, I'm pretty sure. Like somewhere in the front vicinity. I think I picked it up here. It's a Casio. It's nice. It's like a next generation of the one I used when I was in high school. So I really like this model. It's very familiar to me, let's say. Well, check it out after. Okay. With that said, I am going to challenge you right now and see if you can figure out some harder questions without looking at the formula sheet. I'm going to skip the Toblerone box. Please take a look here. I'm going to ask you, whether individually or in your partners or in groups, solve for the surface area of this. You might get some confusions, or what's wrong with my grammar today? You might be confused with what I am asking for. It says find the height of the prism. By height of the prism, I'm talking about this. That's the height of the prism. This right here is not the answer. I'm looking for H, okay? And the surface area is 416. I wonder how much that can help. Work together. I'm going to give you 5 minutes and see if you can solve it. Remember, it's not as simple as just plugging into the equation, as you will see when we take it up. Okay, everyone, I'm going to get to it. I had a certain way of doing it. Nate actually had a different way, and I think it's a lot more ingenious than mine because it uses the same logic as the cylinder. So I appreciate that. I'm going to do mine first because this is probably what very linear, uncreative people like me do. Surface area is based off of 2 triangle faces. I'm sure you got that. Plus, careful here, 2 rectangles for the roof per portion and 1 rectangle for the floor. Why did I separate those 2? They are not the same rectangle. Consider this, okay? Let's start with the area of the triangles. The base of that triangle is a 12. Remember, it's like this. I'm going to draw it here so that you see it. So it is base times height divided by 2, and that gives you 48. I have 2 of them. So 2 times the triangle area is equal to 96. Next, I have the area of the rectangles. I'm going to call them roof. All right? That looks like this. 10 is this height, and I don't know what the long length portion is. The question calls it height, so I'm just going to call it h. But what is the area of a rectangle? It's length times width, so it's going to be 10h. Therefore, what is the area of two of those roofs? 10h times 2, it's 20h. And lastly, the area of the floor, that is another rectangle. What are its dimensions? This I do not know, but this is a 12. That height I don't know, but this is a 12. This is 12h. Therefore, the area of the floor is 12h. This entire thing is the surface area. So the surface area of 416 is equal to 96 with 20h with 12h. I'm going to spill over. 416 is equal to 96 plus 32h. The surface area. The reason why I'm adding all of these up. I subtract both sides. It's 320 equals 32h. And therefore, Ryan, height is, yeah. So this is what I mean by the algebra. You got to show it other than just numerical reasoning, because I could give you some really hard numbers. And that'll be the difference from getting a perfect and getting a 0, right? So try to practice reasoning using algebra. With the grade 10, you will not regret it. Okay? I am now going to show you another way that was provided, and I thought was ingenious. Okay? So I'm going to put this h equals 10 right here. I'm going to use this bottom space. If you don't want to write this down, it's okay. But I want to show you what I mean by thinking. The area of a triangle is still the same. It is 48. Therefore, 2 times a triangle is 96. That doesn't change. But everyone, there's something that Nate did. He pretended that this shape was hollow, just like a cylinder. And if you take this side and you put it flat on the ground, and you take this side and you put it flat on the ground, what do you get? You get a really long rectangle. What is the length of this really long rectangle? The roof is a 10, the roof is a 10, and the piece in the middle is 12. What is the area of this rectangle? It's 10 plus 12 plus 2, it's 32 times h. Isn't that pretty cool? So 416 is equal to the area of your triangles plus the area of your gigantic rectangle, which is 32h, which got the same situation as before. So as opposed to looking at this as 3 rectangles, which I am used to doing, you can look at this like it was a cylinder and open it up like it was a net. And you are both correct. In fact, there's probably a lot more ways to do it. It's up to you. And hence, I don't really care about the final answer per se. I want to see how you did it. Your ability to think and apply is going to be the most important asset for tomorrow's homework check. So please practice. It's a quiz, 1 page, double-sided questions, not as hard as this, okay? But still will ask you to do some stuff. Yes. 1 sheet of paper. Last one. Whether you want to work with other people, you can. Here's the final one. The figure below represents the water tower for a town in Texas. If you were here yesterday, this will be familiar. The city council has decided to repaint, surface. Repaint the entire outer surface of the water tower, assuming it is raised on legs. In other words, if it's raised on legs, you are able to include the floor, the outer floor, okay? Determine the surface area that will be painted, round to the nearest square foot. Here's another example where if you follow the formula, you will get it wrong. Let's backstep a little bit. How many different 3D shapes do you see? 3D shapes. I see a cone, and I see a rectangle. A cone has a flat surface on the bottom. The cylinder has a flat surface on the top and a flat surface on the bottom. How many of these circles are you going to include in your painting calculation? Think carefully. How many of these circles will you include in your painting calculation? Why is that? Huh? They will be facing each other, and are they exposed to the outside? You're not going to paint it, right? Remember, this is a water tower and it's full to the brim with water. This part right here and that part right here don't exist. So if you calculated that as part of where you paint, you would get the wrong answer. Does your formula sheet allow that, consider that as part of its formula? No. So look at the formula and figure out which part of the formula do I need to include for the cone and which part of the formula should I exclude? I'll give you about 5 minutes before I take it up. Give it a chart. If you want to work on it by yourself, you can. But I encourage you to sort of consult and debate if need be. And this is going to be our final example for today. I'm going to write this down. The surface area of a cone is, according to the formula, squared plus pi r s. The surface area of the cylinder 2 pi r squared plus 2 pi r. All right, so this might not be how you thought about it, but I'm going to try to explain it in this way. If you did it in a different way that makes logical sense, excellent. Consider the cone. Surface area of a cone has 2 parts to it. This part and that part. Some of you, like Maddie, for example, wants to solve the entire thing, and visually, you know you're removing the circle, and you know that a circle is pi r squared. So you're going to take this and then you're going to subtract it by pi r squared. Other people might have noticed that this is the circle portion. So they're going to ignore that and they're only going to use that. Both work. Okay? I'm going to put a little green portion here because that's what I'm interested in. For the cylinder, you know that the pi r squared portion is the circular portions. However, you only need one of those circles. So I am going to only focus on just this portion. And the 2 pi r height is the entire side wall of the cylinder. So you need all of this, including the 2. Other people, like Maddie, for example, you simply wanted to just do the formula, and then you know you have to remove a circle. So what Maddie did, I'll do it in red. Maddie decided to use the entire formula and then afterwards subtract it by pi r squared because that's she knows what the area of one circle is. Either work. Ultimately, to find the surface area that needs to be painted, I would do pi times r times s. Luckily, they gave me that. I don't have to use Pythagorean theorem to solve it. Plus a single pi r squared plus 2 pi r height. So this is the pi r s, this is the pi r squared, and this is the 2 pi r height. They are the three pieces that are highlighted above. And I removed the portions I did not like. And if you were to calculate it all, I actually did not get to this part in the answer key. So I'll have to do it manually. Times pi plus pi times 16 squared plus 2 times pi times 16 times 30 gives me approximately 4,825.48. So rounding to the nearest square foot, it will be this feet squared. Final answer. All the parts that are needed for the paint. So long story short, everyone, this is the part that where I'm saying, don't just be so focused on the formula. The formula is only there as reference. It is up to you to decide which parts are important to you and which parts you must leave out. Otherwise, you look like you're not seeing the big picture. You look like you're not quite thinking about it in the large scope, the big picture of things. You must be able to, at this level, see something and choose what makes sense based on your own critical thinking. Right? So questions like this, I think, in elementary and middle school would be like the harder T-style questions at that level. But now that you have grown a bit older, something like this would be more of an expectation as it is, oh, it's a hard question you got to think about. So try to get there, keep working at it. There are plenty of homework questions you can do. We still have a good 25 minutes, I think. It's all on you. As another reminder, tomorrow's quiz, it's basically a homework check. Questions like this, I think, are a little bit on the harder side than what I might present to you on the quiz, but do not underestimate it. Still keep up with the homework, and I think you'll be fine for tomorrow. You'll have plenty of time for it, I promise. And then we'll go from there. Any questions? In fact, everyone, please take some time to do the homework today. Tomorrow, to begin the class, I will take up any homework questions you might have from any of the 3 lessons we did this week. Okay? I will stop this video, and away we go.